Hello everyone, this is Kiran from Talent Development Team. Welcome you all to this today's session on Java programming language. And before I get into session, let me share my screen. I'm sharing my entire desktop. Right. So can someone please quickly confirm, is my screen visible to you? Yeah, thanks Praveen. Right. So once again, I welcome you all to this today's session on Java programming language. As you all aware, as part of March month global learning calendar, we have planned these sessions on Java programming language this week. So the duration is 5 days, and what do you call next week we are planning JUnit sessions also. And please check the global learning calendar. So those who are uh, yet to nominate for other programs, please get into this LMS portal and any relevant sessions you have, you can nominate your name and you can attend those sessions. Right. So coming back to this today's session on Java programming language, as part of this uh, March month, we have planned this, and the target audience for this Java programming language sessions: beginners, those who are completely new to Java programming language, those who are freshers, or those who are as part of global pool batch, like those who are currently undergoing training on various other trainings, right? Other global pool trainings and all. And these sessions will help you to understand the basic concepts of Java programming language. For example, if you want to get into Selenium test automation using Java programming language, this session will give you the fundamental concepts of Java programming and all this. Okay, right. And in case if you have any questions between, please you can use chat panel to post it. And we are recording this sessions. And at the end of each day, I will be sharing the attendance form link as well. So please use that form link to mark your attendance so that we can create your what call we can monitor your we can track your the attendance and as well as create the learning hours. And at the end of the day, I'll be able to share the session recordings also. Okay, right. So that's the plan for this uh, the entire 5 days session. So what we are going to cover in these 5 days, we'll talk about the introduction to Java programming language, language elements, and we'll be focusing on the object-oriented programming concepts in Java. And also we'll talk about main concept like collection framework and exception handling, right? So these are the topics which I'm going to focus in these 5 days. So introduction to Java programming language, we'll understand what is Java, why we should use Java, where we use it, right? What kind of advantage we have. And after that, we'll focus on the language elements. Any programming language you're learning, we should start with learning language element concept. So which talks about the data types, keywords, operators, and all this. Okay. And after that, we'll learn about OOP concepts, object-oriented programming concepts, where we'll learn about the object-oriented programming principles, class design, then object inheritance, polymorphism, right? Abstract class, interfaces. So these concepts we'll learn in this OOP implementation. And after that, we'll discuss about exception handling and also collection framework, right? Okay. Now, let me get into this. So let's start with a question saying, what is Java programming? What is Java? So if anyone asks you, what is Java? How do you define? So can you please use chat panel and respond? And at 12 o'clock, we'll take a short break for 5 minutes. So once we resume, then we'll continue till 12:45 like that. Okay, then we'll take Q&A and all this. Yeah. So PK replied, platform independent language. So please provide your own definitions, whatever you know about Java programming language. There's nothing like what we call correct answer, wrong answer like that. Please, whatever understanding you have on Java programming language. So I'm was saying independent programming language. Okay, right. So let's say if anyone asks you, what is Java? So how do you respond? If any a beginner asks you, what is Java programming language? Object-oriented and robust language. So I'm finding some responses. Right? So Vinod has responded, object-oriented, robust programming language. Anything else? Okay, so let me provide. Yes. So if anyone asks you what is Java programming language, you can simply say it's an object-oriented programming, high-level programming language. It's a high-level object-oriented programming language. You can respond. Okay. So why it is high level? I think we all understand. In programming language, right from the beginning, we have several categories are there, like mission level programming language, assembly level programming language, and high level programming language. In a high level programming language, we write code in a human understandable language, right? For example, if I say C equal to A plus B, so that is something which which we can understand, right? Which cannot be understood by mission. So that has to be translated further into low-level code and all this. For that, we use compilers and interpreters and all this. So Java can be categorized under a high-level programming language, and every programming language has its own methodology of coding. We call it as a programming paradigm, right? Like C, it's a procedure-oriented programming language. C++, again, it's an object-oriented and a procedure-oriented programming language. Like you said, Java, it's an object-oriented programming language, right? So every programming language has a methodology, right? The way how you code, right? And if anyone asks you simply, what is Java? You can say respond. It's a high-level object-oriented programming language uh, which was developed by the which designed. So initially, he is the key person. James Gosling is the key person for designing this programming language and creating the compilers and all this. And the first version was released in 1995. So if anyone asks you who is the father of Java programming language, you can quote James Gosling. And the current version, if you see, we have Java 17, 18, 19 version there. But most of the teams, I think they are using still Java 8, right? Uh, all these versions. And in coming to Java, we have various flavors or categories like we have Java HC, Java Standard Edition, right? Java E, Enterprise Edition, Java ME, it's a micro edition, we call it as, not mobile edition, we call it as micro edition. So Java E, the standard edition, is the core which contains the core packages and all this, core language libraries and all this. Mainly, if you we can use for implementing your desktop-based applications and all this, window-based application and all this. And when it comes to the enterprise, whereas we have component like web services, right? Enterprise integrations and all this, and persistence layer, right? Any web application development, those aspects, and in case if you want to develop any reusable business components, right? So for that we can use the specification like Java E Enterprise Edition. And if you want to implement any software for the embedded system like any handheld devices and all this, for that we can use mobile the micro edition. It's not mobile edition. We can use MB for your mobile phone OS, all this also, but it's mainly for micro edition. We call it as for any embedded systems we can say, right? But I think earlier people were using Java ME for mobile related applications channel, but nowadays I think it's replaced by Android. Okay, so these are the earlier this Java SC, it was called as J2SC before Java 5, Java 6, and all this. We used to call it as Java J2SC, J2E, If you look into the older versions, we can refer them as J2E, J2ME like this. But nowadays, we simply call it as Java SE, right? Java E and Java ME. So these are different flavors of Java, you can say. In case if you are simply, if you want to develop any window-based application or a simple command line interface and all this, we can use Java SE, which is the core, right? So Java Enterprise Edition is for the enterprise level, the server-side applications mainly, and Java ME for your embedded devices, right? All this we can use. So that's a brief about Java programming language. So if anyone asks you what is Java, you can say Java is an high-level object-oriented programming language. And James Gosling is the father of Java language, and first version was released in 1995, right? Okay. Now, and one more important thing, when it comes to Java 1.8 version, right? Java is not only an object-oriented programming language, it is also supporting functional programming features. So Java is a kind of like a hybrid programming language, you can say. So hybrid means supporting more than one programming paradigm, right? So it's not only an object-oriented programming language. If you look into 1.8 version of Java, so it supports functional features also like Lambda expressions, right? Streaming API. So there are a lot of features of functional programming features were added, right? So till Java 1.8, before Java 1.8, Java is an object-oriented programming language only. But right from Java 1.8 onwards, Java is supporting both object-oriented programming language and also functional programming language. Okay, so this is one point you can add additionally, right? Now, coming to any programming language you're learning, maybe Python, Java, Ruby, whatever. So every programming language has its own style of coding. We call it as methodology or a paradigm or whatever, right? So Java is basically it's an object-oriented programming language, and we should aware what makes a programming language as an object-oriented programming language. So what are the concepts it has to support? For example, we have programming methodologies like procedure-oriented programming language. We have object-oriented programming language, right? We have logic-oriented programming language. Like that, we have several types of methodologies or paradigms are there, right? So what makes a programming language? For example, if you take C, which is a procedure-oriented programming language. In a C programming language, the fundamental unit of code is a function. Without a function, you cannot write to a C program, right? At least you should have a main function. Without main also, you cannot write a code, right? So similarly, when it comes to Java, the fundamental unit of code is a class. So even if you want to write a simple hello world code, you must use a Java class having a method like public static void main, and you print something on your console, right? So at least you should have some class definition, the fundamental unit of code. So, and also the other kind of methodology we call as functional programming language. Like if you like language like Erlang, Haskell, Scala, and nowadays we can include Java as well, are the part of this functional programming language. In a functional programming language, we treat functions like a first class objects. Means we are able to pass functions as argument to another function. Normally we see in programming language calling a function, right? When you call a function, you can pass some parameters also, 10, 20, some a comma b, something like that. In a functional programming language, you can see passing functions as arguments to another function. So you can treat functions like a first class objects. And in a functional programming language, the code looks more of declarative. So in programming language, normally we have two categories, imperative and declarative. Imperative means each and every step you have to describe. You should mention the code looks like you're specifying the how part. So how we are implementing it. But if you look at functional programming language, it's more of declarative. In a declarative, you specify what you want to do, but you don't specify how you want to do that. So that implementation logic, you don't completely describe. For example, you take SQL. So in RDBMS, right, we have Oracle SQL or Microsoft Server, whatever. So that SQL syntax is a kind of declarative syntax. You say select star from EMP or some insert into so and so table. These are the values. But you will never say where the database is there, how to reach there, right? So that logic you don't implement. You just specify, I need this. I want to do this. That kind of coding, we call it as declarative, right? Now coming back to this Java object-oriented programming language, since Java is predominantly it's an object-oriented programming language, what are the features it has to support? So if anyone asks you what are the OOP programming features, right? Then you can code these points like abstraction, encapsulation, class, object, inheritance, polymorphism, message passing. So these are the normal concept that a programming language has to support if it wants to be an object-oriented programming language, right? Now, so let's come to each point here. So abstraction, I think most of us give, if I ask you, what is an abstraction? So what is your response? Anyone can respond through chat panel, maybe a one-liner. So how do you define an abstraction in your view? So you don't need to know Java for that. Just define what is an abstraction. Any responses from any one of you? So just you can type it through chat panel. I'm just waiting for your response. So by hiding unnecessary information, display only necessary data. So Pratibha replied, okay. Yeah. So PK replied, hiding internal details and showing only a functionality. Rajesh replied, hiding implementation details. Right. Okay. So we know hiding the implementation, showing the functionality. So showing the, exposing the necessary functionality, right? So for example, I think I give this example in every, and in most of the textbooks also you find similar examples only. For example, if you want to drive a car, so you don't need to know the internal mechanisms, how they work, right? How the brake system works and all this. You need to know how to apply brake, start the engine, right? Changing gear. So these concepts you should know, but you don't need to really know how this the hydraulics works, the internal mechanisms works, and all this, right? In similar way, whenever you are using any uh, electronic thing or anything, like for example TV or whatever, right? You need to know how to operate it, like how to switch on, so changing what do you call, how to operate this remote and all this. But you don't need to really know the how internal circuits works and all this, right? So that way of thinking is called as abstraction. That means giving you what exactly you need and hiding the internal complexity and all this. So that is called abstraction, right? So in object-oriented programming, so we hide the internal implementation details and all this, and just we expose the necessary actions or functionalities to the user. For example, uh, we all, I think those who are coming from CSC and IT background, I think you might have implemented data structures, right, in your academics. In data structures, we have linked list, link W linked list, stack, queue. So when you are using C programming language, you used to write 200, 300 lines of code to implement those data structure functionalities and all this. But when it comes to Java programming language, you really don't need to implement those lines of code to implement data structures concept. It's just a matter of creating an instance of some predefined classes. You don't really know to what you call implement any logic and all this. Everything is there. Just they give you the abstract layer, what you can do with that. So it's just a matter of how to use it. You don't really know how the internal it is working and all this. Okay. So that's an abstract. For example, if you are using electricity, we are all bothering about how to plug in, switch on, switch off, right? But we don't really know from where the source is. So is it a hydro or is it a solar, right? Wind power, from where it is sourced. So those things we are really not concerned about that, right? Now, coming to the other concept like encapsulation and all this. Okay. So in object-oriented programming language like Java, like in maybe in C++ or Python, whatever, encapsulation means binding data members and functionalities together. So that's the definition of encapsulation, right? So binding, that means putting them together. So under one syntax called class. So we define a syntax called class. Inside a class, we put variables and the actions, methods together, right? So whatever properties or variables you define inside a class, they are all going to be used by these methods, whatever you define within the class definition. They are not meant for the outside usage. So the outside objects should not invoke that. So it's limited to within the class premises, right? So that word, technical word you have to use here. Maybe somebody can ask you in interviews, how do you define an encapsulation and all this? You can say technically an encapsulation means it's a binding them together, data and behaviors. Data means nothing but variables, right? Behaviors nothing but methods. Or simply you can call them as functions. But the reason why I'm not calling them as methods and variables is whenever you are using any object-oriented programming language, we have to use formal language, right? So instead of calling them as functions, you call them as methods. It's better you can call them as behaviors or actions also. And you can call them as data, properties, or instance variables, but don't call them simply as variables, right? So what is the advantage of encapsulation is security. If you talk about the programming language like C, in C programming language, if you define any, for example, let me show you this. I say open the notepad, right? If I create any variable like this, I'm talking about C programming language. We have functions, right? We have some functions like this. Now, in a C programming, any variable which you define outside of a function, you can use it anywhere in the functions. Any function can have access to this variable. So anyone can for what you call modify them. So within main, you can modify the stage to some other value. Within test also, you can access and modify it. There's no control over there, right? So there's no security to these properties, whatever you define. But when it comes to object-oriented programming language, with the support of encapsulation, you can put them together inside a class definition so that, and you can also provide some access level privileges and all this, so that the outside of this class definitions, they cannot access the properties. So in case if you want to access any properties within the class definition, we should have access privilege and all this. We can restrict it by using some access modifiers in C Java programming language, right? So the main objective of encapsulation is providing security to your data members. We will have a control who all can be accessed who all cannot access and all this, right? So that's the main importance of this encapsulation. And after this encapsulation, the third definitions we need to know a syntax called class. Right? So class can be defined in multiple ways. A class can be called as encapsulation of data and members, right? So if you, what is again encapsulation? Binding them together. If you put them together inside a class syntax, right? So that we call it as encapsulation. So a class is nothing but it's an encapsulation of data and behaviors. So we can also call this class as user-defined data types. You can also call them as a blueprint or a model or a template. You can use any of these names. You can call it as a data type, user-defined data type. You can call it as a blueprint or a model or a template, whatever, right? So why I'm calling it as a blueprint or a model template means once we have a class definition, we can create n number of objects out of that. There's no, for example, if I have a data type called int, I can create a number of int variables as long as my memory supports, right? So here we can call it as user-defined data type also. Okay. So is there any reason why we should go for user-defined data type? We have data types, int, char, float, double, all this. Why we should go for user-defined data type? Any reason? Anyone? So what is the objective of defining a user-defined data type? What is the need? So can anyone respond to chat panel? What is the need of defining or going for a user-defined data types? So I'm just looking for the response to chat panel. We can use different types in a group, right? So Srinivas replied, we can use different data types in a group. Correct. What else? So there's no for according to our requirement. Okay. So what Srinivas is saying, according to our requirement, we can use different data types in a group. So Vinod replied, user have to define which type of data he is storing. That is the statically typed programming language feature. Okay, right. And one more thing, I think correctly reminded. Java, one of the feature of Java is it's a statically typed programming language. In programming language, we have dynamically typed programming language. We have statically typed programming language. Simply, if you ask me what is a static type programming language, any type of data you are storing for during your computations, expressions, and all this, you must define its data type. So the compiler should aware what data you are going to define and use it in the computations and expressions. So that feature is called as statically typed programming language. So Java is a Java, C, C++, maybe C Sharp also. They all statically typed programming language. If you ask me dynamically typed programming language like JavaScript, you can take and Python. So in Python, you don't need to explicitly define a type of variable when you're storing it. So the type can be decided internally based on the value you are referring to the variable. But you don't need to explicitly define a type of a variable in Python programming language. But in Java, it is must. Because in Java, program will be compiled and interpreted. So the compiler should aware what kind of value this 10, 20 is by using data types and all this. Okay, right. So the reason why we go for user-defined data type, why this class is called as a user-defined data type is, for example, your language provides you different data types like integer, char, float, right? Or Boolean and all this. So what if you want to store data about a person or a book, right? Or a product? So that that type is not available, right? For example, if I want to store an employee ID, I can take an integer or something, right? So I can take, for example, if I want to represent a price of a product, then I can take a variable name of type float or do double like that. But if I want to represent data about a book, a person, right? The real-time objects and all this, then we don't have any predefined data type in our programming language. So if you ask me how we used to do it in C programming language, then we use structures. If you remember, those who are coming from C programming language background, we used to have structures and unions. In a structure, we can group together all different types of variables representing information about an object. For example, a book, a person, an employee, right? A table, something, right? So such kind of data representation, we use what we call user-defined data type that can be defined by creating a class. So creating a class, for example, class employee, class person is nothing but you are creating a user-defined data type. That means not system-defined or a predefined. You are creating for your own purpose of your requirement. Okay. Then in a class, what we do, we group together different information to represent that person and all this. Okay. Now, for example, if you look into this example, so please, you may find some kind of spelling mistakes because I didn't compile this code. I just typed it. Okay. You may find some small errors also. So here I'm representing some data about a student in my programming language because I want to compute uh, grade of a student marks and all this. For that, we need to create our user-defined data like student. So when you look at a student, when you look at any object, right, there are certain features that can distinguish that object from other objects, right? So those features becomes the properties. For example, if you look at a student, how do you identify a student, recognize a student, right? In a group. So we have student ID, a student name. Maybe you can include other parameters. Like here in this case, I'm just adding student subject marks, subject 1, subject 2, subject 3, something like this, right? So in a class, we can define properties of that object. Properties are characteristics, you can also call it as. For example, if you're taking a class called car, so class car has model number, right? Engine capacity, CC, right? Maybe manufacturer. So is it a diesel version or petrol version, something like that. So those properties you can color, length, width, right? So those properties you can represent. Now, it also has a behaviors or actions or methods, we call them. In a class, you encapsulate properties and the behaviors. So whatever properties you define inside a class, they are all going to be used or modified or changed in these methods. Okay. So the methods can use whatever properties you define it here. Maybe simply it uses the property for some computing. It may use it changing the value. And for example, if you take a bank account may have a property called ledger balance. your current balance. So ledger balance will keep on updating, right? Whenever you deposit, whenever you withdraw money, so that ledger balance property will be changed. So that modification operations we can do inside some methods. Okay. And in a class, typically you find properties and methods, also constructors. There is a syntax called constructors. So we'll talk about constructors later. For now, please understand a class contains basically three definitions inside. Properties, you can have properties, and then you can have methods. Along with these methods, you can have constructors. So the properties, what's the purpose? So it is to represent your data about an object. And methods is to provide some computations. Like for example, I want to compute grade of a student marks, right? Then I can use these methods. And third one is constructor, is a special method you define in a class with a purpose to what you call initialize your object in a proper state. The main objective of defining a constructor inside a Java class is to initialize your object. Initializing means giving initial values to these properties. For example, if you take ID, name, subject one, you're just giving some passing on some value to that. That is called initialization. So any object you create in Java program should be in a proper state once you are done with that object creation, right? So that's the purpose of constructor. So the purpose of constructor is not to create an object, is to initialize an object. After creation, object will have certain properties. So those properties should be given some initial values. That is the purpose of constructor, right? So for now, in a class definition, we have properties and with behaviors or methods also you can call them as. Then we have constructors. So this is how the syntax look like in a class definition. So if you define a class like student, you're nothing but you're defining a new user defined data type. So you're just defining a new user defined data type here. Okay. Now, once we have a new user defined data type, so what is the use of simply defining it? We should use it, right? So how do you use a class definition or a user defined data type? We create an object. So if you ask me what is an object in Java programming language, you say an object is nothing but it's an instantiation of object, instantiation of a class. So if you instantiate an object is nothing but it's an instance of a class is called object. So how do you do that instantiation? What is the syntax? So this is the syntax of creating an object in Java class. So if you split this statement, right, the right hand side, we are using a keyword called new operator or a keyword, whatever. And you are specifying, you want to create an object of type class student, right? And once that object is created in memory, so please remember, all objects gets allocation in heap memory area. In memory, in programming language, memory area can be two types, stack and heap. So all dynamic memory will be allocated inside heap, right? Any static, like for example, any local variables in a function and all those will get allocation inside a stack. So this statement new student will create an instance of object of a student, and so that will have a reference, right? So that will have some memory location. In that memory location, these values will be assigned. For example, the student ID. So this 101 will be initialized. Student name. So this name will be initialized. Subject 1, subject 2, subject 3, these marks will be assigned. So once the object is created and after the installation of the what you call properties through constructor, right? So that object reference will be returned. So that returned reference will be assigned to a variable here. So here on the left hand side, if you see, so there is a variable, a reference variable called Prakash, right? It is of type student class. This is holding or referring an object of type student class. So both data type on the left hand side and right hand should be matching. Maybe in some cases we can have a higher data type and lower data type, but here most of the cases, what we call the data type should be matching here, right? So what you are creating here, you are creating an object of student class and assigning this properties to those variables, and that object reference you are assigning to a reference variable. So this Prakash is not an object here. It's a reference variable of type student, which is pointing to an object of type student class, right? So instantiation of a class is called as syntactically an object. You can create a number of objects for a given class. There is no any restriction that one or two only. You can create a number. Right? So hope you all understanding it. Are you all noting down what you are discussing? Okay. Thanks for the quick confirmation. So we just discussed about the encapsulation. What do you mean by encapsulation is? And then class definition, what a class contains, then what is an object. Then we have another concept like inheritance. So inheritance also one of the most important feature a object-oriented programming language has to support. If you talk about any object-oriented programming language, it has to support a feature called inheritance. So what is the definition of inheritance? So simply acquiring properties from one class to another using a syntax called extends keyword. So in Java, acquiring properties and behaviors from one class to another class is called inheritance, and we use a keyword called extends. And the advantage of inheritance is reusability. So without reinventing the wheel, you can use existing base class, then you can derive the subclass out of that, and you can add some customized code and you can use it, right? For example, if you take the object like a bank account, so there are different types of bank accounts are there. There is no single bank account only, right? We have fixed deposit account, current account, loan account. So there are several data types are there, several types. So here what we do, we define one common class definition called bank account. So every bank account has certain common properties and behaviors. So if I have a bank account, then I need to produce my details like customer name. You will have your bank account number, address, and all this. These are properties. And similarly, if you have a bank account, you can perform some actions like withdraw, change PIN, right? You can deposit, so you can transfer some money and all this. So such actions are behaviors. So these actions and properties are common across multiple types of accounts. What I do, I create a base class called bank account. I write in some actions and properties into that. Then that class I can derive into subclasses and all this, right? So the purpose is reusability. Instead of repeating the same thing in multiple classes, why don't I create a common class with all the common properties? And then I can make it visibility across multiple subclasses and all this, right? So that concept we call as inheritance. And one most important thing is in Java. So Java supports single inheritance of classes. So Java doesn't support multiple inheritance of classes, single inheritance of classes. Right? So this is the one major important point that we need to know. So Java supports single inheritance of class definitions. So if anyone asks you why Java supports only single inheritance, why not multiple inheritance and all, you can say to reduce the ambiguity issues of multiple inheritance and all this. So there's no any reason behind. So that's the reason the why Java doesn't support multiple inheritance and all this. Okay, but it supports multiple inheritance in case of interfaces, but not in terms of class definitions. So this is also one point in it. And coming to another most important thing, polymorphism. So it can be implemented in multiple forms, multiple ways, using static polymorphism and using dynamic polymorphism. So static means what you call method overloading, we call it as. Dynamic overloading can be called as method overriding. So in method overloading, we write multiple methods inside a class with same name but with the different arguments. Okay, so that is called method overloading. And method overriding, any method you define inside a class, if you further improve it and implement it in subclasses, that is called method overriding. Right? So an object can have multiple forms. So this word, I think it's a derived from a Greek word or something, multi forms, many forms, right? So these are the features that programming language has to support in case if it wish to become a object-oriented programming language. So any object-oriented programming language, if it wants to be, right, so it has to support these features: abstraction, encapsulation, class definition, object, inheritance, polymorphism, and message passing, right? So these are the concepts that makes a programming language an object-oriented programming language. So hope all these points are clear. Like this, we have multiple types of programming paradigms: procedure-oriented programming language, we have functional programming language, we have logic-oriented programming language. So please spend some time to understand various types of programming methods we have, like functional, object-oriented, repetitive, what you call logic-oriented, procedure-oriented. So have a look at all these definitions. Okay. Now, so let me move on to another important thing before I show you the hello world program and installations and all this. So why we should learn Java? What the advantages and all this, right? So if anyone asks you, tell me one reason why we should use Java for this implementation of a project and all this. So these are a few points that I made. There may be, you may find a number of points there, but these are the core points that we can say about Java programming language. So first thing is it's a simple language. So when I say it's a simple, it doesn't mean that it's easy to learn and master it and get a job. So that's what not I'm not talking about in that context. So simple language means the code, the syntax of Java language looks similar to C and C++. So those days before Java, most of the systems were written in C programming language, right? And if you want to migrate to Java, you should not be wasting your time in learning a new syntax and semantics. So you should be able to directly port your application into Java programming language. So that's the reason if you look into Java programming language syntax, it is very much similar to C and C++. You don't find too much difference also, right? So in that context, Java is a simple language. It doesn't mean that it's very easy to learn, get a job, master the subject and all this. Fine. Now, another language element is multi-threaded. So it supports multi-threading API. So we have concurrency APIs and all this, right? And most importantly, third one. So one of the major advantages of Java programming language is portability, platform independence, right? So what do you mean by that is, so anyone define what is portability? Can anyone? So can anyone use chat panel and respond? What is portability is? What is platform independence? So we can execute on any operating system, right? Okay. Shraddha is also saying, okay, yes. Fine. So once you write code in your programming language, ability to port, ability to run your application on multiple platforms, that is called portability or platform independence, right? For example, if I write code in C programming language, let's say the simple code, and I name it as, let's say, demo.c, right? So if I write some code in C programming language, if I try to compile it and run it, then what happens when you try to compiling and all this, obj files will be created, the .exe file will be created, right? So then you will run the exe file and all this. So the ultimate file will be demo.exe, right? So what is demo.exe? So what this demo.c contains, we know. It contains the code which is human readable. So this code has to be further translated, interpreted to low level by using C compilers and all this. So once we compile and link it, then what happens finally? An exe file will be created. So this exe file of this C program contains mission instruction set of your platform. For example, if I'm compiling this code on Windows 10 or whatever, so this demo.exe contains mission instruction specific, which can be understandable by that platform only. So if I want to take this exe file onto Linux and execute that, it doesn't work. Okay, so that is called portability, ability to run your program on multiple platforms. So that's one of the important. So how, here the question is, how Java achieves this portability? So that's the important thing, right? So any reason how Java achieves this portability? How this is possible in Java programming language? Any responses from you? So there's no response. So hope you all there. So it converts the code into byte code. Yeah. So how this portability is possible in Java? So in the behind scenes, how the things works, right? Now, so let's understand how Java is popular for platform independence and all. For example, in Java programming language, you write a simple hello world program by creating a class, by creating a public static void main method, and you're printing something on your console, right? And you save this code with .java extension. Like, so in C programming language, if you are not using any ID, I'm talking about Java, sorry. In Java programming language, if you are not using any ID, so you can compile your Java code in the through command prompt, right? So how do you do that? You simply compile it by running this command java c. So there's a once your Java is installed, we need to set the path and all this. So once your Java is installed, then you can use Java C, Java compiler, which can read the source file. There are no any errors, then it will generate a dot class file. Dot class file is a intermediate file between your source file and the executable code, exe file. Okay. Now, so this dot class file contains bytecode. So if anyone asks you what this dot class file contains, you can say it contains bytecode. So bytecode is not a human understandable code, is not a mission level code also. Either in either mission nor humans can understand this bytecode. Then there should be someone who should understand this code and translate this code into further into mission level code and execute it, right? So that is nothing but assembly code. Okay. So your code will be converted to dot class file. So here what happens? Dot class file will be generated, contains bytecode, and then further you run it. If you want to run your Java program, then you simply say Java hello world. You don't need to say dot Java and also. This will trigger your the hello dot class file. Okay. Now, so we'll take a quick break for 5 minutes now, and at 12:06 once we resume, then we'll continue for around 30 to 40 minutes more. Then we can close the session at 12:45 around. Okay. Yeah. So let's take a break for a quick break. So I'm just stopping this sharing mode and pausing this recording also. So welcome back. So before break, we were discussing about the introduction to Java programming language. We learned that Java is a high-level object-oriented programming language, and it is also a statically typed programming language. And James Gosling is considered as a father of Java programming language, and the first version was released in the early 1995 or somewhere, right? So, and we also learned about the Java programming language features, the object-oriented programming fundamentals, like concept like abstraction, encapsulation, class, object, polymorphism, inheritance, right? So these are the features supported by the programming language. Now let me share my screen. Sharing my screen quickly. So can you please confirm? Is my screen visible to you? Okay. So we are just learning about the advantage of Java language. In that we learned that it's a simple language. So simple doesn't mean that it's very easy to learn Java and understand and get a job. Simple in terms of syntactical wise. So those who are coming from C program background, they don't find difficulty in migrating to Java programming language. I think most of the syntax are same, right? And multi-threading, it supports the concurrency APIs and all this. Platform independence or portability, ability to write the code once and you can write it anywhere, right? So now, normally any code you write in programming language C, what happens? The exe file concept, right? So exe contains mission in a specific instruction set. So every architecture platform, right, has its own what you call instructions and all this. So similarly, if I work on Windows, then that Windows exe I cannot run it on other platforms. Now here in Java, what happens once you write code with a .java extension? All Java source file are saved with .java extension. So once you compile it, if anyone asks you what is the outcome of compiling a Java program, you can say outcome of compiling a Java code is dot class file. So dot class file contains byte code. What is byte code? Byte code is an intermediate code which JVM can understand, translate into mission level code, right? So there should be someone who can understand the byte code, which is written into dot class file, read it, and further translate into low level code so that your code can be run, right? So that's JVM, so Java Virtual Machine. So please understand each platform has its own JVM. On Windows JVM, we have Linux JVM, Solaris. So there's no platform independence in JVM. So we have mission specific JVM versions. For example, Windows JVM knows, right, how to convert a byte code into Windows specific instruction code and run it, right? So Linux JVM, so any JVM you install on, because if you want to run a Java code, the fundamental thing is JRE, Java Runtime System. If you want to write Java code, compile it and build it, then we use JDK. So whenever you install Java, right, we get two things, JDK and JRE. So Java Development Kit, it's mainly it contains the core libraries, packages, right, compiler and all this. So if you want to compile, build your code, then we should use JDK. In case if you want to run your code, the existing dot class file within runtime environment, we need the JVM installations and all this, right? So these concepts are important with respect to this Java platform independence, why it is, how it become platform independent and all this. So in Java, once you write code, you can run that code anywhere. You don't need to modify any source code, nothing, right? So simply you can carry that dot class file to any platform and you can run it on top of that JRE platform and all this. And one more advantage is automated memory management. So nowadays, I think most of the languages are supporting this feature, automated memory management, garbage collection, and all this, right? So, for example, if you are dealing with programming language like C, C++, whenever you create any dynamic memory area in heap, using some functionalities like malloc functions and all this, we should definitely deallocate memory. Whenever you allocate memory, we should responsibility is to deallocate also. So if you deallocate, if you forget to deallocate, what happens? That memory location will be unnecessarily reserved. So that means that you are wasting the memory space and all this. For example, any object, if it is not referred by anyone, if it doesn't have any references, it is of no use, right? For example, if you just define an object employee one, and no, we are not referring it, then what is the point of keeping that in memory, right? So any unreferred and what do you call any object which is having no references in Java, those all will be marked and deleted by a special process called garbage collection. So garbage collection means automatically your memory area will be scanned for the objects which are not having any references, right? Then it will be deallocated. So memory will be safely deallocated and you can, so that you don't need to waste your memory area and all this. Fine. So that is the automated memory management. So as a developer, you don't need to worry about all those removing memory spaces and all this. You just deallocate and whenever you find an object is not in reference, then it will be simply deleted by the garbage collection process. And also one more advantage is robust exception handling. So normally in programming language, runtime errors can happen. So whenever you're running your program, any sudden event, uh, any abnormal event may happen, right? So how do you tackling those abnormal events? That is the most important thing. So in Java, we have a mechanism called exception handling. by using a syntax called try catch, by using which we can handle these exceptions and all this. So exception means any abnormal runtime events. So that can occur definitely during runtime of your application. Whenever it happens, how do you respond to that so that your program cannot be what you call what you call terminated and all this. Okay, right. So these are the common most important advantages of Java programming language. If anyone asks you why should I use Java programming language, you can quote these points. I'm not saying these are only points. You may quote some parts like distributed application development supported, right? So enterprise level applications we can implement in Java. So there are many other advantages out there, but these are the main core important advantages of Java programming language. So simple, multi-threading, portability is the major advantage of Java programming language. Then automated memory management and exception handling, right? So in Java, how you compile your Java source code, we use a JavaC command line tool, right? Once you compile, the outcome of compiling a Java code is dot class file. And once you run the code, how do you run the code? We using Java command line tool. So Java space your bytecode dot class file. You don't need to prefix that dot class file here. You can simply say hello world. Then the JVM comes into picture. Read this dot class file line by line. It translates into low level code and execute that. So in Java, we have both compilation and interpretation phase. So the compilation, that means source code converted to bytecode. So this process will be taken care by compiler, right? Dot class file is the outcome. And running your program means reading your bytecode file and converting it to mission level code, executing your code, that is taken care by JVM, the interpreter, right? These points are most important. Right. So let me move on to other points. So another important concept is any language you are learning. First, we learned what is Java. We learned that Java is a high-level, object-oriented, statically typed programming language, and we learned about the principles, object-oriented programming principles like encapsulation, class, inheritance, message passing, and all this. And we learned about why we should use Java, what are the advantages, and then before I show you the sample code, hello world, and how do we write class definition and all. So let's understand the most important thing, the language elements. Any programming language you are learning newly, we should understand the language elements first. So what makes the language element means data types, keywords, literals. Literals mean nothing but defining values and all this. Identifiers, operators, control structures. These points makes your language elements, right? Now come to the data types. So data types means we all know, right? Any type of data you are storing in your programming language for computations. For example, if I want to do A plus B or something, so this A and B value should be read, then stored into your programming environment, right? So we should specify what kind of data type this A is holding, this B is holding. That we should specify. That can be done by using data type. So in Java, we have two types of data types. We have primitive types and we have reference types. So two types of data types we have in Java, primitive and reference types. So primitive means, as you all aware, the data types like byte, short, int, long, char, and all this. Right? So these are most of the programming languages you define. For example, C, C++ also you have these primitive data types, right? And the reference data types means like strings. Like for example, if you want to represent employee object, product object, right? So those are references. They are not primitive types, right? So primitives means these 8, right? So we have byte, short, int, long, and all this. And most importantly, we should also know how many bytes this data type occupies. So this byte data type occupies 1 byte of information. Short occupies 2 bytes of information. That means 16 bits. So all this size which I mentioned here is in terms of bytes, not in bits. For example, if you take integer, int, in Java it occupies 4 bytes. No matter which platform you are running in, you may be running your Java program on Android. You may be running Java program on Windows, Linux, 16-bit, 32-bit, whatever. Everywhere, Java integer means it occupies 4 bytes only. So that way it will help the programs more platform independent. So otherwise, for example, if you look into C, C++ code, I think C program, it all depends upon the compiler platform in which you are compiling your code. Your integer may occupy 2 bytes or sometimes it may occupy 4 bytes like that. It all depends upon the platform or environment you are using. But in Java, no matter which platform you are running and all this code, integer, long, char, all these data types, they occupy same size and across multiple platforms. There is no change in the data type size, right? So that's one of the advantages of Java programming language here. So here always byte is 1 byte. For example, if you take float to represent numbers with decimal positions, right, with some precision, we use float, 4 bytes. If you need more precision, then we go for double with 8 bytes, right? That means 64 bits. So long we have 64 bits again, so 88 bytes. So when it comes to Boolean, so Boolean means either true or false, right? Yes or no, a true or false. To represent true or false, you don't need 8 bits or something. It all depends upon the implementation of your platform. On how we are implementing on your platform, it occupies size. I cannot say Boolean occupies 1 bit or 1 byte or 2 bits like that. So nothing, it all depends upon the implementation here, right? So that's why I'm using this not applicable here. We cannot say Boolean means 1 bit only. If you ask me, 1 bit is sufficient, but it all depends upon the platform, the implementation of your Java language, how much space it occupies and all this, right? So these are the primitive types. We have 8 primitive types starting with byte, short, long, char, bool, boolean, float, and if anyone asks you, tell me about string object, strings. So strings are not primitive types. So this is one important point we need to understand. There's no primitive types like strings. So primitives are, the strings are reference types. So all strings in Java, which you represent within double quotes, they all represent like an object of a class called string. So there's no primitive type string. There's a reference types, right? So that's about the data types. So we have primitives and we have reference type. So reference types, one of the reference type is a string. You can use other types of, you can create your own class like employee. Then you can create your own instances. So like that we can proceed. Yeah. So that's about the data type concept in language elements. So another is operators. So whenever you are performing any computations, writing expressions, statements, right? We compose it with operators and operands. So for example, if I'm writing an expression saying a result equal to A plus B. So this result A and B, we call them as operands. They hold some values, right? So the symbols which you use to perform calculations like plus, minus, subtraction, they are all operators, sorry. They are all operators. We have operands, A and B result, and operators, all symbols, A plus B and all this. So what are the different types of operators we have? So operators can be categorized into multiple ways, like arithmetic operators, right? Logical operators, increment and decrement, assignment operator, bitwise operators. So these are common things you find in C, C++, most of the programming languages. For example, if you take arithmetic operators, you say plus, minus, division symbol, modulus symbol, right? Logical operators. For example, if you have two conditional expressions, like for example, if I A greater than B and A greater than C. So A greater than B is one expression, A greater than C is one expression. So if I want to concatenate together, if I want these two expressions to be true, right? Then I can use AND operator. So increment and decrement, plus, plus, minus, minus to what you call increment the values, assignment operators to give you a new value to your variable, bitwise shift operators, any values if you want to modify at bit level, right? For low level computations and all this, we can use bitwise operators, right shift operator, left shift operator, and right shift unsigned operator. For example, if you look into this third symbol in this row, unsigned right shift operator, we call it as. So it works like a right shift operator, but it's mainly meant for the unsigned, that means positive values, not for the negative values, right? And instance variable, new operator is to create an object, conditional operators. So just like if else statements and all, we can use ternary operator called conditional operator. So this can be called as a ternary operator also, right? And relational operators, so which will give you some output in Boolean expressions. For example, A greater than B, less than B, right? The result of this relational operators expression is Boolean, right? So these are different types of what you call operators we have. So language data types and then operators, right? Now, so another language elements is keywords. So any language you take, every language has its own set of keywords. Keywords are the words which their meaning is defined by the programming language. So keywords definition we cannot change. We cannot provide our own meaning to the keywords. Their meaning is already defined, which we can use it, but you cannot modify it, right? And whenever you're defining any identifiers, so identifiers cannot be named with your keywords. For example, I cannot have a keyword called if. I cannot have a keyword called while, because while, if, they are all keywords, right? So in Java, we have very vast list of keywords. So Java's keywords is not that compact as C and other languages. So we have around 50 plus operators, the keywords are there, 50 plus 3 or something. And all keywords are in small letters, right? So if you look into any keyword, all keywords are small letters. So small a to Z. And also we have reserved literals. Normally we call them as reserved literals, null, true, false. These values we call them as reserved literals, but they are we can consider them as form of keywords only. But if you ask me, better we should call them as reserved literals. So as part of these keywords, right? So, and for example, a concept called literal. So what is a literal? Literal is nothing but a value. For example, if I say int a equal to 10, so this 10 can be called as a literal. So literals are basically immutable objects. Uh, Here, because you cannot change this 10, right? Uh, you cannot insert and all this. So 10 is a literal. For example, other literals are null, true, false. They are also literal values only. So literal means the value, just a hard-coded value in your expression statements. Right? And coming to the another language element, we talk about the identifiers. Right? So identifiers are nothing but the name given to methods, variables, packages, class definition. So the name given to something is called as identifier. So that something can be a method, variable, or a package, anything, right? So what are the rules for defining identifiers in Java? The rules are simple. Identifiers should be composed of alphabets A to Z, either capitals or small letters. And it should use numbers from 0 to 9. And it can use some special characters like dollar, underscore. But no other special characters are allowed, like space character, like that. So there should not be any space between these identifiers you are defining. And there's no restriction on number of characters in a identifiers. And identifier should not start with a number. So identifier should always begins with a alphabet. Sometimes it can begin with a underscore, but it should not begin with a number. So that if any identifier is beginning with a number, that is invalid definition of a keyword. Your compiler can catch that, right? So for example, if some of these keywords you are defining here, book name, book underscore name, underscore book name, right? So these are some valid. For example, if you take a wrong invalid definition of a keyword, you can say, for example, here I'm using the numeric. So keywords are case sensitive. Java is a case sensitive programming language. So Java can clearly distinguish small and capital letters. So for example, if I define a variable with small a and capital A, both are two different variables, right? And quickly coming down to structures, control structures is nothing but your loops and if conditions, a condition structure like if conditions, right? So in Java, we write if conditions like this. So the expression should be evaluated to a Boolean expression only. So any conditional expression you're writing within if condition or while condition, wherever, it should be evaluated to a Boolean only. We cannot use other than Boolean, right? So here, if else, so you can have a simple if condition, we can have a if else, and we can also have nested if. That means if condition inside another if condition. Depending on your requirement, you can have nested if conditions, and we can also have else if. So if more conditions you are checking, then you can use if condition. If it is not true, else if this condition is true, then you want to do some statements. Finally, we can have a else statement like this, right? So we can also have a switch case statement. So switch case is a multi-condition statement. You can say with one case statement, we can check the various. We can execute multiple statements and all this, right? And reputational structures, we call them as loops. while loop, because these concepts are not focusing because we are all aware of the syntax, right? So for example, you take a loop called while loop. So while loop, you are just creating a variable and you are writing a condition expression here. So as long as this condition is true, you want to execute this statement inside. So as long as this condition becomes false, once condition becomes false, it will come out of this while loop. It will not execute the code inside, right? So if this expression is true, then it will get into this while loop. Otherwise, it will come out. And similarly, like while, we have another flavor called do while. So do while we call it as exit control loop. So one important thing about do while is it checks the condition after executing the iteration. In while loop, in the beginning itself, the condition is checked. That's why it's controlled. It is called as entry control loop. So if this condition is checked at the end after executing the set of code, that is called exit control loop. So the minimum number of iterations in while loop is 0. Sometimes in beginning itself the condition is false, then it cannot execute the while loop. But in do while, the minimum number of conditional iterations is 1. Okay. And for loop syntax, I think this is common traditional for loop I'm using. So Java also support enhanced for loop. For each statement also supported in Java from Java 5 version, Java 1.5 version onwards. So in Java, two critical versions were there. So one is 1.5 and one is 1.8. So in 1.5, there were several features added. Later, generics concept, right? For each, whereas I think so several features were added in 1.5 and 1.8. So it added features like functional programming features, lambda expressions, streaming API, and so many things, functional interfaces, all those concepts, right? So that's about the for loop syntax. Okay. So just to execute a code, let me show you. I'm using Eclipse IDE here. So tomorrow we'll discuss what all things you require to work on this. So here I just quickly show you some statement like in Java, if you want to put anything on console, right? So we can use a system.out.println statement. So hello all. So once you store that, you can just run this class, public class main having public static void main. So don't worry here. So tomorrow again we'll discuss that. Then you can run it as Java application. Then output should be displayed here. Okay. So in today's session, before I close, let me summarize. So we discussed about the brief introduction to Java programming language. What is Java, when it was released, what are the different flavors and all this. Then we learned about the OOP concepts, the OOP principles, right? So what makes a Java programming language an object-oriented programming language, the features supported by, and we also learned the advantages of Java language, why we should consider Java programming language compared to other programming language and all this, right? Most importantly, the portability or platform independence is the reason, right? And we also discussed about simple language elements like data types, keywords, operators, control structures, right? These concepts we learned. Now, before I close today's session, let me share the attendance for today. So all of you, please don't go. Just before I give you this attendance, let me, yeah. So Srini was asking what is the real usage of interfaces. So in Java, if any type you want to define, that always should begin with an interface, right? For example, if I want to define a type called list in Java collection framework, it starts with an interface called list. Above that, we have collection interface like that. And below interfaces, we have different implementations. So the data type definition should begin with an interface. Okay. So before I share this attendance link, let me stop this recording mode now. I'm sorry.